Today, we are going to speak about the designing a cooperative sustainable future. I'm very happy to announce you, to present you our presenters. So we have with us that has visited us so from the Czech Republic, so from Prague University of Economics. So Tomas Sigmund, you see him. So he will speak about the subsystem approach. We also have together with us from the University of Oviedo and also from Madrid Open University, Antonio Muñoz, who will speak about automation in the benefit of autonomy. So myself, also from UDIMA, and also related to other institutions collaborating or cooperating in the development in this workshop. That I will speak further. I actually start this morning about cybersubsidiarity, but designing freedom, seeing it in more detail. And finally, Teresa Guarda, who had to disconnect for a moment, but she will turn back about lights and shadows of the Internet of Things. So thank you to everyone who is participating in one way or other. I just remind we have the different channels we send to the people who is participating through Meet, and we also have this broadcast channel of the University of León. I want to thank as well to all the institutions that has helped us to make this workshop, and particularly the one that has hosted this session, which is the University of León. We are in the library. Sorry, not the lab. Is the library?
Yeah.
Library, yes. Oh, bibliothèque. Bibliothèque. No, it's library.
Library.
Sometimes
Library.
yeah. So the library of San Isidore. I just wanted to mention San Isidore because San Isidore, that people who is coming to León, they are hosted in San Isidore. San Isidore, he was one important figure in the history of humanity because he felt in the beginning, in the old Middle Ages, he had the feeling that the ancient world is going to disappear, and he felt the call to collect all the knowledge that could be collected. So he did an amazing work, even considered one of the earliest ethnographic works. So of course, not following the method that today people would be angry of the method he followed, but nonetheless, so San Isidoro work, which is an encyclopedia, put the grounds of what later on would be the university and other institutions for the development and the creation of knowledge. So he has been a very relevant figure in the history of the science altogether. And the work, which is the etymologies, is a kind of an encyclopedia. And I just wanted to say these words because our glossaLAB is kind of in the same vein. So we also want, in some encyclopedic way, to try to collect and to clarify concepts and to create the space for the better understanding of each other and the matters at stake. The word to Tomas. He will be speaking of the subsystem approach, which is an interesting way of dealing with complexity, and is somehow connected to what we saw this morning, what we were discussing this morning. So thank you very much, Tomas.
Okay, may I use my microphone or?
No, I think it's can't be heard.
Can you hear me?
Yeah.
Okay.
Because it's here.
Okay, it's here. I'll switch the presentation. Oh, yeah.
Maybe I have to stop.
Yeah.
No, it's free.
Okay.
And you?
Let's see.
No, but make it show
Okay.
the presentation.
Yeah.
Don't share that. No, it doesn't.
It doesn't work.
Now you, yes, now you have to change.
So I have to share the whole screen.
Yeah, so when you share, just share. So first do this. No, yeah.
Oh, okay.
Now you start the presentation. Start the presentation.
Just the presentation.
Yes, start the presentation. Throw the presentation. Throw it. And then go to Meet. Then share only that.
The screen?
Not the screen, but
The whole
no,
screen.
not the phone. No.
The window.
Yes, exactly. And then you select the
Okay.
that one. Okay.
Yeah, I think now it works. Okay. So I'd like to thank José and all others participating for the invitation and for the possibility to be here and to share some ideas I have and I developed at my university and also with my friends, which deal with the system thinking, the impacts of technologies, also of the social aspects of technologies, and also we deal with some philosophical ideas, because even though I'm currently at the University of Economics, I'm originally a social scientist, a philosopher, who has to consider also other aspects, not only the philosophical one, but my main approach is the philosophical. But today, or in this session, I'll be presenting an introduction to soft system methodology, which was developed by Peter Checkland. To give you an introduction to this methodology, I'd like to start with some general ideas, more general approach. And Peter Checkland distinguished or differentiated his soft system methodology in contrast to reductionism, where the main area of concern are just parts of the whole. So you want to construct the whole from the parts, but don't respect the whole. That's the reason why it is just reduction, why it is reductionism. So it starts from the parts and then comes the whole, just in the second step. It's not the primary area of concern. The problem is that the whole cannot be understood or constructed just from the parts, because there is something more than the parts in the whole. And that's why he supported or designed or was supporting the alternative to reductionism, which is holism. Holism starts from complexity, and it states that the parts can only be understood in relation to the whole. So there is something like a dialectical relationship between parts and the whole. The relationships between the parts are very important because they determine what the parts are, what their role in the system, in the whole is. It's very relevant because you may also know movements like structuralism, which doesn't consider the parts as essences, as substances, but only the relationships between them. So it's, from our holistic perspective, also a little bit reductionist because it doesn't consider the parts. But I'd like to stress just the idea that it's also possible to have just the whole, just the relationships, without the parts as independent substances. In the holistic view, however, there is a dialectics of system and parts, because the system provides sense to the parts and the parts provide existence. It's similar to the dialectic between matter and form in the Greek philosophy. There is also some freedom in the existence of the system and its parts. So we have to deal in relationships as a process, because systems are changing, the systems interact with other systems, and also the parts interact with one another, and there is a flow of matter, energy, and information between the system and its environment, and between the parts within the system. And the systems theory claims that the order is just an emergent property of disorder. So the system may be destabilized for a moment, but then a new order is produced or created. Just to give you an idea what the system is, we can differentiate physical systems like rivers, biological systems like living organisms, which were at the origins of system thinking. The system thinkers were inspired by biological systems above all, because in the living systems you have parts, you have organs which communicate and interact with one another, and that gives life to the whole system, to the whole body, which is the purpose or aim of the whole system. There are also man-made systems like cars or clocks or anything, which have one purpose, and everything is subordinated to this purpose for which they exist. There are also social systems like family, which is a whole. Every member of the family has his own purpose, his own expectations, but they also form a whole, which is combined out of these different purposes. But there are also human work systems, like different organizations, which are combined and to form something like a state or an economy or something like that. And the systems methodology as such is a set of ideas and procedures which are used in problem solving. Systems thinking is very inspiring because it teaches us how to see the world through another person's eyes. So it considers or allows us to see and to respect another point of view. It's very important today in the global society when we meet people from different cultures and different backgrounds. So one of the very important ideas of system thinking is that it respects and recognizes that every view of the world is just limited, that there's nobody who can understand the world properly and into every detail. And another idea of system thinking is that there are no clear experts. Everybody has his own perspective, which must be respected, but also this person must respect another people. So it's very democratic, this system perspective. Just to illustrate my point, I very often show this picture of Ernst Mach, which is how one perceives the world through his own eyes. So we start from this subjective perspective, but there is also a common world which we must respect, which is pointed to by the library, which is next to the lying person on the left. So there are always there's always a clash or mixture of perspectives. There's the subjective one, which we can't get rid of, but there's also this common one, the common world, the natural world, which we share with other people, and which allows the different perspectives to exist. Human actions can also be considered as a system because human action is purposeful and intentional, but people can have different purposes and different intentions. Machines, on the other hand, just fulfill purposes, and biological systems we don't know exactly, but in any case, we attribute purposes to them, which can be survival or another purpose can be finding a partner in life or evolution or something like that. But we don't know exactly if it's their purpose or why they follow these purposes, but in any case, their activities are so structured and so accommodated, they can allow constitution of this or fulfillment of this purpose. Human actions consist of different roles, different purposes, and we have to respect them, or at least find a platform for the respect. That people have different perspectives and different opinions is reflected in the fact that people have different models of the situation, and every model is influenced by the worldview of the person. We can differentiate between changes within the worldview, which is the first step or the first order perspective, but there can be also changes of the worldview, which is the second order perspective, which is more complex. And we can find this differentiation in cybernetics, the cybernetics of first order, and there's also the cybernetics of the second order, where the worldviews are also changed and adapted. Now we are coming closer to the soft system methodology, which was developed by Peter Checkland, as I have already mentioned. The hard systems also exist, and they're different from the soft systems because they have quite clearly defined objectives. We know what the hard system wants to achieve, or we want what we want it to look like, what we want it to be like. But the problem with this methodology is that it can be applied only to a specific type of system, which has clearly defined or determined relationships which don't change in time very much. We use this type of system, for instance, in supply chain planning, in path plans, in systems analysis, in operations research. But for the soft systems, which consist of people with different opinions, which can change, different backgrounds, this hard systems thinking is not sufficient. And that's why we should develop the soft system thinking to overcome these differences, these problems, these shortcomings. Also, the reality is very complex and variable, and a mathematical model is not sufficient to consider, to include all the variables, all the perspectives, all the problems. There are many perceptions of reality, and very often we don't know what we want actually to achieve. We can find that situation in politics, for instance, where everybody has a different perspective, this different expectation, the aims are different, and it's very difficult to find a consensus. That's why Peter Checkland developed and suggests his soft system methodology, which is devoted to finding a common point of view from various differing perspectives. First of all, these different perspectives must be explored and also externalized somehow, because people very often don't know exactly what they want or what they think. Another contribution of this theory is that people must learn from each other and must learn that other people have different values, that there are different cultures, different opinions, and also prejudices. The The result of this methodology is not always the original, achieving the original aim or the original intention we had, because it can change in the process of achieving the outcome. But we must assure that all the stakeholders agree to the goal, even though it's not the same goal they presented in the beginning of the methodology. The principles of soft system methodology consist of finding the purposes of various stakeholders, respecting the diversity of views, then seeking a mutual understanding and consensus between them, also resolving any conflicts which can occur, and they also want from us or ask us or requires from us to change our culture and to adapt to one another. As I have already said, this methodology is very suitable for systems or problems which are only purely structured. The aim is very often to maintain the relationships, not only to achieve the goal. And that is why the how of the method is also important. Not only what to do, but also how to do it, so that we respect others. It is a breaking, or there's a difference between the functionist paradigm and the soft system paradigm, which are completely different. Because the soft system methodology considers that systems or models are just constructs of participants. There is no objective reality. Reality is constructed or is influenced by our culture. And that is why we perceive or stress just some parts of the reality. The objective reality is a similar construct to the subjective one. It also considers that there are actually two systems. Everybody is a system, every person is a system, but also the society or organization is a system. So man is, as such, is his own system because it has borders, it has environment, it has parts which are combined together. But this system, the person, is also part of a larger system, be it the state, the family, the organization, the company. And we have to combine these two systemic perspectives. So to sum up, the check-lens methodology is very suitable in situations where there are many objectives, different views, different assumptions, different reasonings, different interest groups, and also very complex problems where the relationships may also change in time. Check-lens suggests some basic steps in this method. The first one is to make a picture, he calls it rich picture of the problematic situation. The picture should contain people who pursue everybody his own goal and purpose, and also we can illustrate somehow or represent somehow how they understand the world. Then we create models of purposeful activities for every perspective. So we make models for every perspective of every worldview. They are different. These models are used as sources of questions and also a source of discussion about the problem situation. And in this discussion, the different perspectives and their backgrounds are revealed. And they also help us to structure the discussion. These models are also used to find different versions of the situation and different changes which this perspective requires. Then the changes are implemented, and usually once they are implemented, they trigger other problems which are then also solved, and this process is in check-lens world works never ending, because one solution produces other problems which then must be solved as well. Just to give you an example, if we consider a concert, there are various perspectives on the concert. It can be a source of entertainment for the audience. It can be the source of income for musicians. It can also be used as a demonstration of power and authority of the person, the guarding personnel, of the security personnel. Some fans come to the concert to show their tribal identity, to fulfill their needs of belonging, for example. It can be also a marketing event, because somebody can support it or contribute some marketing materials. It can be also a source of some money for the city or for the village, for the municipality. It can be a source of publicity for the music group or for supporters of this event. And it can be also used as a demonstration of the young generation's ideas, who can present their ideas or their perspectives. So there are many perspectives on one event, and we have to understand them and then try to combine them in order to achieve a common perspective or a common approach. It can be shown that this methodology claims that technical problems are different from managerial ones, that we as managers, or if we want to manage something, we mustn't consider just technical problems, but also the soft problems, the human problems. It considers complexity and ambiguity. It criticizes the technical optimization, because it says people are learning, and every situation, every event is a source of learning for the participants. It considers culture, history, values, opinions, and it considers also that systems are just thought constructs; they are not objective. We are coming to the end. Here you can see the 7 steps of the methodology. They take place in 2 areas, or in 2 environments. The first one is the real world, where we describe the world and also implement the changes. But below the line, you can see the system thinking environment, which is more free, something like a fantasy or imagination, where we are not limited by the real world and its impact, but we are free to think. This is the area where we design the definitions of the systems and also produce the models of the systems for every column, so to say, which is the specific perspective which can be differentiated against another perspective. Just to go through the phases, the first phase is the problem, which must be captured in a picture, which is called rich picture. It's rich because it contains many perspectives, many relations. It should also include people, conflicts. Checkland recommends to use your own hand to draw the picture, because if you use some available tools, they can mislead you, because they will suggest something which is not in your intention. Then we jump from the real world to the world of systems, or to the world of our imagination. Here we create new definitions. So we take one holon and produce his own perspective, which consists of this ketvo elements. Ketvo is an abbreviation of 6 components, 6 elements. Checkland recommends to start from the T part, which is transformation. But from my experience, it is better to start with worldview because it forces you to respect the perspective of the person, not just the transforming part. Checkland was originally an IT man who worked for companies, and that is why he likes the transformation part, because he's used to it from the business life. But from my perspective, it's better to start with the worldview, because it's more illustrating, I think. Apart from ketvo, there is also a betvo, which is another development of this idea. The ketvo has C as the customer, which is the one who has some benefits from the system. In the later development, Checkland substituted the C with B and didn't consider the customer, but the beneficiary. Then we have the A, which is the actor, which is somebody who delivers the benefit. Then there is the worldview, which I've already explained, the owner of the system, so the one who has control over the system and also owns the system. And there is also the environment, which is something which is outside the system, but influences the system in any case. We have to ask what are the different perspectives on the situation, which is included in the worldview, and also the relationships between the elements. Just continuing the example of the concert, the transformation would be to feel like a member of the fan community. The worldview would be the identity of the fans, which is a basic human need to belong somewhere, the need of belonging. The customers who have benefits from the concert are the listeners, the audience. The actors who provide the benefit are the musicians. Then there are sponsors who finance the whole event, and environment are the rules, some legal regulations, and also maybe the band history. And to make a sentence out of it, we may say that this concert, in this perspective, in this holon, in this worldview, is a system in which listeners satisfy their basic human needs to be part of a community by listening to music at a concert in the environment that fosters the creation of a shared space. Then we produce the model. I think I don't have to go into details because it's a little bit technical in this case. It just says that we, out of the holon, out of the definition, the so-called root definition, we produce a picture which consists of different activities. And then in phase 5, we go back to reality from this system perspective, or from this imagination, compare the model. There are many models because there are different participants and everybody has different perspectives. So there are many models, many root definitions, and we take one of them at a time and compare it with reality. The result is that there are some insights and suggestions for improvements. And then follows discussion, where different perspectives and models are discussed with the stakeholders. And they have to adapt, or they learn to understand others' perspective and also to change, adapt their own perspective in order to allow the fulfillment of others' opinions. There are some tools how to do it: structured discussion, unstructured discussion, scenario modeling, real-world modeling, anything. Actually, Chikrin doesn't give many details on how to do it. He gives freedom, for which he sometimes criticized that he's not specific enough. But he says, okay, everybody can choose what he wants, what suits him. In the phase 6, then we produce some desirable and feasible changes, and the methodology goes back and compares the changes with the models and asks if every participant is satisfied with the results. We also have to consider 3 types of analysis. We have to analyze the owner, who has the authority to carry out the activity. So we have to ask who will be responsible for it, and if the owner will allow the change. We should also analyze the social system, which says how the different roles, norms, and values are related to the conceptual model which we produced. And also we should consider the political analysis. If we didn't change the power relationships, who will introduce the change, and how the power relations after the change will be affected. So how the owner will be affected, how the social system as such will be affected. The social systems means the background, the values, the preconditions, the presuppositions, etc., and also the power relationships, how they will be affected by the changes which we devise. And then comes phase 7, which is the improvement of the situation, which was settled in the previous step, in the previous phase. We must ask to what extent does the actual situation match the model, and if it was possible to fulfill all the requirements. Also, how the situation has changed. And Chikrin says that at this moment, a new cycle should start, because every change causes some resistance, and we have to try to come to a conclusion again, which is also one of the results, that solving one problem usually triggers another one. The work is never completed, actually. It's like the life of man. And then we also have to consider that the steps 4 and 5 also influences the whole picture, so that should be repeated as well. So I think that was the introduction of the soft system methodology from the wider perspective. Chikrin himself developed in his life various versions. I have presented, I think, the most didactical one, the one which is the best understood, in my opinion. But the details of the methods are not so important. The idea, the principles are what is important. And I hope I have contributed somehow to the system development of the world and solving the problems which we are facing. So thank you for your attention.
Thank you very much, Tomas. Does anyone wants to make a question or to make any comment? Of course, you put it in a nutshell. A lot of all the subsystem methodology. By the way, I'm very happy to greet Rafael. Hello, how do you do? we are missing you here in Spain. We don't hear you. We can't hear you. Maybe you're.
It was the system of my bed and real world, and now I am in the system back. I'm struggling with the real world and the system. Yeah, but you won a little bit late, so sorry very much for coming late.
No. Don't worry. It's a pleasure always seeing you. I want to ask you. So this morning we were talking about the utilization of the viable system model, and you made good a point of the problem of the closeness of the viable system model. Do you see any interplay, so the possibility of bringing together the subsystem approach with the viable system model?
Well, viable system model is more strict. It doesn't allow as much freedom, and also doesn't consider the backgrounds of the participants, like their perspectives, their presuppositions, their cultures. That was very innovative for the system methodology, that it considers also the background, the sometimes unconscious aspects of our thinking. But on the other hand, I think it can be used, the viable system methodology can be used as a modeling tool to model the different perspectives, because I think it's very complex and considers parts which every system must have, like the system 1 interacting with the world, the system 4, which is the planning and presenting of the system outside. So I think it can be used as a model, as a starting point for modeling, but it should be also supplemented with this cultural analysis.
Yeah, but so when you are, imagine we are creating an organization or we are organizing whatever. Yeah. So a community, it can be a team, it can be a larger community, and we want to find out how to regulate ourselves. So for example, in the town, so we need to find how we want to work. Then if we cannot say all the time, this is what I see, this is what you see. No. So at the end, we need to find out a kind of general will, even while we keep the particular wills, like so with the original idea even of Rousseau. So if an organization is going to be kind of a system that can operate and can follow some particular objectives, these objectives is like the materialization of that general will, and at the end, so you can have a model that is just one instead of having different perspective.
Yeah, that's what Checkland is also aiming at, to find a conclusion. And I think the conclusion may also be the viable system model, but it can be a combination of various viable system models, respecting the perspectives of the participants, but can be combined in order to form a common viable system model, not just the one.
So so Rafael, you were okay. That's also.
Sorry, I came too late, but I think the last words I heard, I could see problem between reality and how we look at reality. I think this is a basic philosophical problem since many times. So what I could understand from the end of your presentation is that there's a tension between the real world and the way we look at this real world, and it is a back and forth permanently between both. So we cannot forget the real world of the war in Ukraine, but we have to deal with bitter Putin. I would put it like this in some way. So if weapons are speaking in this time, At the same time, we have to look for a diplomatic solution for the war, which is exactly what we are doing. And so we cannot say it is better the diplomatic to get the diplomatic solutions and only to use the speaking of weapons. And I think this is the issue now. When language stops and weapons talk, to put it in a very cynical word, then it is very bad for the system and very bad for reality too, for the people who are suffering and dying and so on. The issue we discuss now in Switzerland, as you know, is exactly this: how to bring the people who are using the weapons to speak, to come to table and to talk about the weapons and about the real world. And I think you said also there is no final solution for this. We have to keep on going and trying to bring the people into a talk, into the table, and to stop the language of weapons. I don't know if this is what you wanted to say. I don't know if this case.
Because there's no respect when we combat. There's no respect and no consensus. It's just violence and disrespect. And I completely agree. We have to talk and to understand one another. But once the weapons start, there's no room for communication. Yeah. Because the one who fights doesn't want to discuss.
Yeah, there is a breach of the system, so there is not anymore. It doesn't work. So the cooperation doesn't work anymore. So we are in that situation. We are so far apart of the viable system model. We're the opposite side. The opposite. And in that situation, maybe the subsystem approach is interesting in the sense that you have so different views that you need to consider, even the ones that you don't even want to consider because you find it they make no sense. At least try to understand those perspectives.
What I find very interesting in the Czechland's perspective is that it considers that people are sometimes not aware of the background of their ideas. There's something hidden in them which they don't understand. It's similar to analytical psychology. People do something, but they don't know exactly why. And Czechland attempts to reveal that, to externalize that, to force people to explain why they do this, why they think the way they think. Of course, it's a never-ending process because you can never come to an end. We have also learned from Freud and others, Jung. But we should try to do that. And it can help us to understand not only others, but also ourselves. When we talk to others who are different, we also learn how different we are. This is also very, very enriching perspective for us. So everybody can be enriched with the communication with others, which is, I think, a very good point Czechland makes.
So it's not exactly the same, but that has reminded me to Ramon Llull, what Ramon Llull wanted to do in the Middle Ages. So when there were religious fights and the people say, no, I state this, and the other were stating something different. Say, no, I'm going to analyze the language. Let's see, don't fight anymore. Let's check, because maybe what you are stating is even against what you are really believing deeply. And sometimes what you're stating is actually not in contradiction with the other. So it's like to clarify what you are actually doing and what are you acting upon, things that you consider that is completely different and at the end it's not. And so this clarification is interesting, but goes like in that line.
And it's a story of, I don't know, he meets his sons, or I don't remember the story exactly, of the Llull.
Ramon Llull, no, he was a monk. And,
but he wrote a book or a story.
I don't know about that. I don't. But what I'm talking about, so in the Ars Magna, he explains about how to analyze the language and how to find that there are some correspondence between two different statements, taking into consideration the different beliefs of the basic principles of, for example, one community and the other community, and through the combination. That was the idea that was taken later on by Leibniz in the Mathesis Universalis. The idea of Ramon Lull said, we are not going to discuss anymore in science, we will just compute. So the idea that you can put it into a logical form and to see what is consistent with in itself, what is consistent with the system of axioms. And it just reminds me. So the fact that often it is the lack of clarification, the lack of not having really in mind what you are stating and what you are acting upon. So also as we were discussing yesterday, for the failure of the method of phenomenology, that there are some beliefs that you cannot be aware of.
So you forget, or you want to forget, or you didn't realize. It's very often.
Or you don't even realize because you're acting upon. It's like if you that is what Ortega puts in a nice metaphorical form when he makes the prologue of poetry, where he discussed the method of phenomenology in 1914 after Husserl wrote the method. He says, use the metaphor, if I am walking, there is so I cannot put into the part of the ground that is below my feet, because I cannot step anymore. So I am standing upon, and I'm walking upon. Is anything I'm walking upon? All the beliefs that are acting, those are difficult to reflect and to be and to be conscious of. So the subsystem methodology would make it clear, more clear, so for all the participants.
But it doesn't mean that we shouldn't attempt, we shouldn't try, even though the reflection is never perfect. It's always biased or imprecise. We should always try to reflect or to know what's going on. It's the basis of science and improvement and
so of course we need to move and it's clear. So when as Rafael has put it, when the weapons speak, then we need to find other words.
There's no time for reflection.
There is no.
We are
time for it.
We are covered, or we are involved so much in the activities of the fight that we have no time to reflect for reflection. It's just combat. We're caught by the situation.
Okay, so thank you. Any other comment or a question? No?
Okay,
so in a way, I am going to continue what we were discussing this morning. So from the ethical issues that we will, as I said before, we will continue with that tomorrow. So I did present about the cybersubsidiarity model, and I will, by doing that, I will try to cover two objectives. On the one hand, to speak for the problem we are dealing with of designing a sustainable future. But on the other hand, I also want to show you what is the approach. So for the glossaLAB that we are using in one of the aspects, and so the glossaLAB has like 4 different levels. One of the levels is the technical level of developing the platform, so to make that the cooperation in the clarification of the concepts and the different approaches can work, and the different people that participate can do it simultaneously, and we have also the system for reviewing and all that. So the technical part of what we also want, so from the higher level, even so, for example, when we try to see how the network of the concepts, or how the knowledge system that we are building up can be seen. So we also develop some tools for that. This is in the technical part. The other is the theoretical part. so for the clarification and for finding more useful and more intensive definitions, and so more intense system of contents. So that means that we can reflect larger extension with a shorter intention of concepts. This is put in terms of the intentional performance, as we call it. Then we have the third, which is the meta-theoretical level of reflecting about how we develop this knowledge system, or how through our contributions we are approaching so positions and perspective, or we are having better connections or not. How are we integrating? How diverse the integration of knowledge is? So the different measurements and the different perspective of how the system of knowledge is evolving, so to see it as over time. That's the third. And finally, the fourth is about bringing about sustainability for the system to make that it can work over time. So with the different cooperation that exists, with one university here, another university there, this other institute that is providing some resources, and with all these parts that are cooperating together in order to make that the system work. So we have also a particular approach, and this is what I'm going also to show. So I will go into more details of what I spoke this morning about the cybersubsidiarity, and I use one title that was actually a title given by Stafford Beer. There was a collection of lectures that were broadcasting by the Canadian broadcasting system, or I don't know whether that was television or radio, but it was very interesting lectures that were put in the form of a book that has exactly that name, Designing Freedom, because what we use, as we have discussing before, is related to the viable system model, but it is not completely reduced to it, as we discussed this morning. So the idea, just recalling, and I do this briefly because the people who is here is not the same one who were this morning. So just recalling very quickly the principle of subsidiarity that was developed by Althusius in the ending of the 16th century and beginning of the 17th century. As I said this morning, so he were a kind of a representative of the Calvinist community. The Calvinist community were immersed in a world in a Catholic world, and they wanted to have the benefit of both. So this Catholic world was working in some respect well, but at the same time, the Calvinist community, they had a system of values that were kind of particular, different. So there was a fairness, some values were shared with the rest of the community, but others were particular. And he wanted to find out a way in which these both systems are compatible. So how it is possible that I can live in my community, I can solve the problems in the community, and at the same time, I can also participate on this larger community, the community of Catholicism, in which there are many common things, and I also want to work together with other communities. So he devised the idea of subsidiarity, that the idea of subsidiarity has been generalized later on in the 19th century and in the 20th century. System science has taken as a principle also to make that the parts of the system that solve the problem should be those that are closer to the problem, so that at the end we are more effective in the utilization of the resources while confronting problems. And at the same time, because the system needs to cope with all the problems that it has, so always the reaction and the confrontation of the problems needs to be done at the level in which this is more effective. So in some cases, Like, for example, if we are speaking of the Catholic world, some issues are better confronted at the level of the whole system, and other systems that only concern to the Calvinist community, for example, then they can be dealt just within that community. And in other cases, just the individuum can solve it, because only regard the individuum himself and can be just regarded only from that point of view. And all the levels in between we can put the municipality, and we can put larger communities or organizations. So that was the idea of subsidiarity, and the combination of cyber is to use because we were speaking also of the information system, how to use the information system as to make our world so more adaptable to the needs of the people, and also to the preservation of the system itself. So the people, the biosphere, and so on. So we actually need to make that this last longer, that we just not let the wars, the weapons speaking, and that's make it not durable. So the idea, put it in terms of the network, because this morning we were I was showing this network perspective as to see how we can play with that, stating that it's not enough the network, but the network is what enable us to see like the grounds where the system can emerge, and at the same time, so it's like the territory in which different systems or different agents can cooperate with each other, either to do something, to do an organization, or just to make their own living. So just interacting because they make their own wills and their own needs. And so is the network is like kind of the space for the evolution and the dynamics of this complexity of agents. And we need to have something which is not like in what is being shown on the left is the perfectly centralized system, like in a bureaucracy, that we have the center of laws, and then we have the effectation of all those laws. We need something more than just the hierarchical network, even it has different levels. So on the right, we have the solid lines that represent the hierarchical networks. We also need some horizontal networks in order to make that the subsidiarity can be brought about, can be developed. We need that the agents at a given level can interact with each other to solve the issues at stake. So the model of cybersubsidiarity means that we require different levels, so we can nest systems that are capable to organize themselves and to solve their issues. Like, for example, an individuum is a good example of autonomy that can solve a lot of the problems. Many of the problems that happens to one person can be solved by the person herself. In other cases, actually, most of them, we need some cooperation. But the cooperation often is just at a short range. We can do it with people that are beside us, so our family, our companions, our teams, and we also can have institutions that work. We can have other larger systems that work, like the scientific system and the social system, because we will speak of the glossaLAB so as an example of bringing about this cybersubsidiarity model. The idea is to use the model, the variable system model, for the organization of something that is durable. What the Stafford Beer tried to find out are the necessary and sufficient conditions to make that system is durable. And as we were discussing this morning, it is interesting, this example of the Mondragon Cooperative Group, in the sense that they never follow the model of Stafford Beer. They started from scratch, as making that the system work. It is a good test that the system worked, the fact that it lasted already for more than 70 years and has been so successful, integrating through many different situations the capacity of adapting. So they never follow the model, but when one Tibernetician came to make a diagnosis of the system, John Walker found out that this model, so the organizational model for the cooperative group of Mondragon, was a perfect instantiation of the viable system model. So the interesting thing is that Stafford Beer was just looking for the necessary and sufficient conditions for a system to last. And while checking one of the systems that were doing that very well, so adapting and so on, they were actually meeting all those requirements very well. So the system, the viable system model, so is composed by system ones, which are the ones that are actually interacting mostly with the environment, is the ones that are doing things, which is they actually have most of the interaction in regards to them. So most of the complexity is being solved at the level of S1, so which are the operative systems, the systems that operate upon the problems that we are dealing with in the environment. In some cases, there are cooperation between system ones of the same kind. They can be seen, for example, a team cooperate with another team because there is something in common. We need some components, like, for example, we in glossaLAB, we are different teams, and they can cooperate separately, but we also need some elements that facilitate that this combination of this cooperation work well and is stabilized. So that's also something necessary. And this stabilization is what is being provided by S2 that facilitates that the cooperation works well. And then the S3 is what makes kind of a strategic planning of what we want to do all together. So, in general, we need kind of planification of that kind. And in order to see that this is being met, we also need an observation. So the performance, so how this is being done. These are the performance indicators. But at the same time, we need to look forward. We need to know. We need to have some model of the system, how it is and how it's going to evolve, and to predict what is going to happen. And if we have some opportunities, for example, for next year or several years in advance, we also need to have some idea of what we are, and to see also what the environment is going to be. And if we make some decisions, then that we want to implement it and to take us on, because it's a good opportunity. So with S4, which is the one that is looking for the future and to forecast and to see what we want in advance, is communicating with S3 to make the strategic planning, which is for the now. So S4 is like for the future. And finally, S5 is what represents the identity. So we as a group, we want this, we don't want that, we will never do this, this is what we want to foster, and so on and so on. So kind of how we identify ourselves as a group. And this is, of course, fundamental, and it's kind of the last regulation or the last decision element for the system to determine so what we want to be and what we don't want to be. There is also an idea which is very interesting. So from Stafford Beer, which is the algedonic indicators, which is similar to, so it comes from donic, so pleasure, and algedos, so it's pain. So the combination of pleasure and pain. So if something is pleasant, it's good. If something it hurts, it's bad, we need to avoid it. So there is the possibility that if something is really going wrong, So the system 5, so what we are deciding ultimately, say, stop, we don't want to go forward. So there are good biological examples. I don't go in that. But the interesting thing of the model is that Stafford Beer, he used the model of the bodies, of the biological systems, and particularly the human. So the system. So system ones are like most of the organs, like including the muscles and the skin and all that is what enable us to interact. System 3 is like the sympathetic system. System 4 is like at the level of the diencephalon, and then we get the midst of the senses. And the S5 is the cortex, is what corresponds to what happens in the cortex. If we consider that in terms of information, it happens in the body, in our bodies, that most of the information exchange. So in terms of nervous impulses and also exchange of chemicals between one part or another, they only happen at the level of system 1. Practically most of it happens at the level of system 1. And even if we want to see this in a lower level, for example, cells that interact with other cells, so most of the communication between two cells is just for that communication between them two. Only for the tissue, a little bit is required, or for the organ, is only a little bit of that communication that happens at the level of only one cell or one cell with another. So most of the information happens at the level of S1. Then we have higher, a much lower amount at the level of system 3 with respect to system 1. But this is in any case very, very important, because this is regulatory and makes that different. For example, our muscles they can cooperate together to make difficult movements, like for example walking or holding something. It's really complex, and they coordinate very well. But this is done kind of very well automated in a kind of S3 system, which is in our spine. But the amount of information is small. If we compare that with the amount of information to S4, this is again a level lower. And finally, if we go to the cortex, to what is the amount of information taken to the cortex, that's practically nothing in comparison with the amounts of information that is being shared at the level of S1. So something which is very important for the viable system model to be implemented in a complex system, which is not our case. So the glossaLAB at this current moment is enough to be at one level. So if more than 10 agents are cooperating very frequently and constantly, then it happens that we need an additional level of organization. If we have more than 20 people, it's good to have more than that. But at the current time, we have teams that are not that large. So for example, the ones that are working at the technical problems, so they can work just in just these teams. So it's affordable at this level. But in case that it would grow and that more people are participating, actually we need to take into account that at this time most of the people who is participating in the development of the technical parts and so on, we are a few. But when people start to work more in the theoretical, we need to organize a much larger group. So we have like about 60 people who are going to participate. So we will need an additional level. The idea of the viable system model is that it is kind of fractal. So it will always replicate with the same structure. So it requires the same, because it needs to be sustainable so it needs to be long lasting. So it needs to last longer. So they all need to meet the requirements that was determined or was found out by Stafford Beer. So we will need more levels. I will explain very briefly so how we how we do it. Just to give some ideas that in 2 days will be explained in a more detail by Manuela. So we have some panels to see what is the performance that we are achieving. So for the system, how it's working regarding some parameters that we consider relevant to see that it is well done, that we are not accumulating many problems, that we see when we are going to meet and so on. And then we have some tools that are useful for us to see what needs to be done next and what are the problems, what resources I need next to organize meetings. So everything put together to make it as simple as possible. And the same structure should be replicated at any level. So this is something that we have also proposed for the organization of other projects in which more people are taking part, like for example the COOPLAB project. Then this morning I was speaking and mentioning the importance of filtering. The idea of filtering is a key idea because we don't need to exchange all the information, and actually something which is very important to preserve the privacy and to preserve the autonomy. It is that whatever can be solved at the level of one team or at level of one person or at level of one municipality and so on, that's information that can be kept at that level. Doesn't need to be shared at higher level because it's not going to solve any issue at the next level. So then we need to have an organization of the information that percolates from one level to the next, and this is one kind of filtering that we have relevant rules. So if this is relevant because we are solving some problem in the next level, then okay, we need to filter that, and in some cases it can be aggregated. So we don't need to keep all the information, like for example, what is being done with all the what the digital giants are doing with our information. So we need so this is the relevance filtering, and there are some additional indicators, something that we also need to be open. Going to the idea of the subsystems, we can also consider that maybe we need to add something to our view, and to see that a different perspective is worth considering. Then other filtering, which is important, and in that regard, probably so the subsystem approach is not useful. Is the Kalman filtering for that is for previewing what we are going to need. So we collect so the performance indicators, only those that are relevant, for example, for the system to be well organized, and we want to predict. So upon those indicators, which does not represent exactly how the system is, only what we measure, which is not exactly the same, we need to have a model of the system, and we use this through Kalman filtering to use through the measurements this model, so we can see how the system is based upon the measurements that we do. Like for example, we see this week we edited three articles, and 3 were reviewed, and 3 were not answered, and so on and so on. By keeping all those indicators, we can see how the system is based upon the model we have, which is using the Kalman filtering, and this is kind of the same. So how the current state is being calculated using the model for which we use here the transition model, the control input model, and so on. So this is just the technicality of how this is being implemented, the Kalman filtering. And all that is being built upon very easy tools. We actually So right now it's not working yet in our platform. We have another platform in which we make it run, and our purpose is developing in the glossaLAB platform right now. But it's as simple as that. So using, as I insist, very simple systems. We collect the data that we require. This data is being stored. It is being filtered, and the filtering is being shown in terms of the performance indicators. In other cases, the information is what enable us to find out what are the, like, for example, the next assembly, or there is some alert and so on. And this is so how we implement, the way we implement what I showed you before. And this is the picture of the prototype we developed with some example of the things we got to develop to see. So the performance indicators of some of the parameters, like the platform is functional, the number of articles that are elaborating, and some ones are in red, so bad, some ones are in green, that they go good, and other ones are in yellow, we need to take care, and that's it. So that is just the idea of how to use this model of cybersubsidiarity for designing the freedom. In this case, the freedom of the making the glossaLAB platform work further. Okay, so thank you for your attention. Any question or comment?
How far is the implementation of this model in the glossaLAB? Is it already working, or is it just a...
So what I showed you before, it was working, but it was working in a previous platform. So in glosarium Vitri, we had it working in glosarium Vitri, but in glossaLAB is not working yet because we have some issues that we're not able to read some of the files, but this is a technical problem that we will solve. So that's one of the issues, and the other is to solve also about the filtering. So we need to refine. So we did an implementation. So that was a prototype. There was one guy who did the thesis on that, and that was presented like 1 year and a half, and which is published. But then the next step is to implement it in glossaLAB. The problem is that we don't have so many people and time so working in that, but we go on. Anything else?
And is it your idea, or you were inspired by the viable system model, but the development is your idea?
Yeah. So as I said, we speak of the cybersubsidiarity. So let's say the original part of it, because it's the viable system model, as I explained this morning, is kind of the operative part. But we consider the network as the space for the emergence of the systems, and this is like the open side of it. This is one side, and the other is about this filtering. So I see here. So with Wolfgang, we present also the idea for as a kind of a background, more than a background, like an axis for the organization of the information at the global. So for the global organization of information, the paper was ICTs connecting global citizens. Okay. And there was also the idea of the Austrian guys were also to implement something in the United Nations, also to facilitate the communication in the sense of subsystems, in the sense of subsystems. But for making that the information exchange operate, we propose this. So this cybersubsidiarity model, and then this idea of the using the Kalman filtering, yeah, this is something that we added later, so like 2 years ago. The combination of these two kinds of filtering. Any other thing to be done?
Well, so some days ago, José María asked me for preparing something related to the automation. And well, this is the title that he thought for this presentation of automation in the benefit of autonomy. So, well, the idea of this presentation is just to bring some idea about this automation and, well, show you some example of this kind of automation that you can apply, or I have applied in my expertise field, which is the audio signal processing. And well, finally, I would like to conclude showing you how we are using the automation in the glossaLAB project. Okay. Well, first of all, I would like to introduce you to the concept of the automation. Here you can find a brief description. Automation describes a wide range of technologies that reduce the human interpretation in a process. Okay? Human interpretation is reviewed by predetermining decision criteria to process a relationship and related action. So, we can understand this automation as the way to reduce the interaction that the human has in different processes. One of the main or the key point of the automation was the Industrial Revolution. There you have a figure of the first, I'm not sure if it's the first, but the steam engine, okay, which suppose a relevant point in the development of the processes in our societies. Well, so I would like to show you some examples of how we can automate some process, or for example, or how we can apply this automation in several tasks. Okay. For example, here we have one of the projects that we have developed in my research group. This one is related to a process which is called audio to score alignment. Okay. Imagine that we have a musical score, and also we have a recording of a specific performance. Okay. So, well, the idea of this process of automation is just to match the different events that we have in the musical score with the actual performance. Okay. So, imagine that you have a long musical performance about, I don't know, several minutes, and you want to match each point of the audio with each event in the musical score. This process can be done manually, but as you can imagine, it's very tedious because you need a musician labeling each more or less each second in the musical score. So this is a bit not complex, but very, very tedious. So the way to solve this problem, or the way to automate, it's very difficult to say this word, automate this process is using, for example, the signal processing. Okay. So we developed this, we have this signal model, which consists of, well, several blocks, where we, as an input in this model, we have the audio signal of the actual performance, and as output we have well, a measure. Well, not a measure. We have this last block that relate each second or each time in the performer, in the audio signal, with each event in the musical score. Well, in order to do that, we apply, as I told you, we apply different blocks. First of all, we apply the FFT of the audio signal. Then we apply a specific representation of the musical score, and after that, we apply a function that compute the distortion between this representation of the musical score and the input, the audio input, the input of the audio signal. So we compare both representation, the FFT of the signal and the representation of the musical score, and well, applying this algorithm, the DTW, we find or we match each second in the audio performance with the musical score. In this work, also, what we did was to develop an application just to identify a specific performance among a huge database. Okay, imagine that you have several musical scores stored in your computer. Okay, you have a huge database with musical score, and well, you have one performance, one audio performance, and you want to find the specific music score in your database. For example, if you have, I don't know, 300 of musical score stored in your database, if you had to do this process manually, it could be really very complex, because you need to review all the musical score you have in your computer and compare this musical score with the input signal, the audio input signal that you have. Okay, so the only way to solve this problem, and also if you want to do that in real time, is just to automating the process using, for example, in this case, well, the different audio signal processing technique. So, well, this is one example of how to use the automation to solve a real problem. Here we have another one. Imagine that we have we are in a concert hall, and we have several instruments playing at the same time. And well, imagine that you are one member of the audience, and you want to focus only on one single instrument or type of instrument of the concert. So the idea of this work was just to well, develop a method that can separate the different sources that we have in the performance, or the different instruments that we have in the performance, and of course do that in real time. The way to do that is just to, well, we record the performance of the different instrument, the mixture, and well, of course, we apply the FFT, okay, the representation, and then we apply several methods based on, well, non-negative matrix factorization, well, just to factorize the mixture in the different instrument that we have in the performance. But if we want to do that manually, it could be really difficult because we need to, if we want to do it manually, we need to find those FT, frequency and time bins of the mixture, and yes, we need to distinguish between all of them, or we need to label all of them and assign them to a specific instrument. So this is not, I mean, we cannot do that manually. We need to use some specific system to perform the separation of the different sources that compose the mixture. So this is another example of how to use the machines to automate some specific task or engineering task. Here we have another one more related to a health system. Here we have, well, another example where we are capturing an audio signal of your head, because when we use a microphone and put the microphone over the chest, we can record both the hair and the lung signal. So the idea of this work was, okay, if we take this mixture as an input, okay, the hair and the lung as an input, we want to develop another system that can separate both the head and the lung. So we perform again another method that can separate both sources, and then in this case we apply another method just to infer or estimate the heart rate of the subject. So, well, this is another example of a real application where the machine are used to automate the process of the process of the source separation and then the heart rate estimation. Okay. Well, regarding the glossaLAB project, well, this is a bit different, but here we have we have developed another method to automate the importing process, or the import process of the encyclopedia developed by Charles Francois. In that case, we start by our algorithm take as an input the LaTeX code of the encyclopedia version of the Charles Francois, and from that point we develop an algorithm that is able to identify the specific the specific part of this LaTeX code, or the specific information containing in this LaTeX code, and translate that information to a specific format that can be imported in the glossaLAB platform that is based on MediaWiki. Okay, so here we have another example of how to, because imagine that we have to do all of this process manually. I mean, this encyclopedia is composed of several concepts, several terms. So if we need to import all of these concepts manually to the glossaLAB platform, we will spend a lot of time because we need to do that one by one. So it's very tedious. So the idea that we have here was to develop a specific program that can take as an input this LaTeX code, identify the specific information that we need, or the specific concept of the encyclopedia, then organize all of this information in order to have the possibility to import inside the glossaLAB platform. Okay? So this is the way that we are importing the encyclopedia developed by Charles Francois in the glossaLAB platform. Well, that's all. Thank you for your attention. Maybe José María can say anything else about all that, or what? I don't know. Are you there? I think that we cannot listen to you. So Maria, I think maybe you are mute. No. I think that you need to unmute the Aurelio Garcia Primo computer. Could be? No.
No, era para preguntarte cómo se...
Now we can listen to you.
Ya está resuelto. Vale, gracias. Okay, so I just wanted to give some figures that we have like about 6,000 articles on the Encyclopedia Charles François. Only the Encyclopedia Charles François enumerates more than like about 2,000 different works, and we don't only have in Charles François Encyclopedia, but we also have a Krippendorf dictionary of cybernetics, and we have the dictionary of North America, of the North American Society for Cybernetics. So altogether we have an amazing number of articles. So we cannot cope with them unless we had an army of people. So bringing all the content and separating the parts.
We need to automate the process just to import all that information in the glossaLAB platform.
And the automation was also being done at the previous step. So this was done carried out by Gerhard Krust automated, because what we had was the coding provided by the Kreuter that has the coding just for printing with very specific coding, very strange. He did an amazing work also to find out how this was codified, because something was very strange, just useful for them to print it out, but not to generalize. So what is being shown in gray, that was already being carried out. So when we put it into LaTeX, then from LaTeX it's easier, for example, to take into PDF. So what Antonio has mentioned is about the automatic. So it changed towards the glossaLAB platform. So that last step. So
yes, what we are doing is just from the LaTeX code identify. What we need to do is just to identify the specific command of the, because as José María said, it's very easy to convert from the LaTeX to a PDF file with all the contents, but it's a bit more complex to go from the LaTeX code to the glossaLAB, because we need to identify all the specific command from LaTeX, and we need to convert that command to, well, not just convert, we need to extract the information that contain this LaTeX code, and then arrange all of that information in order to create a specific template to import that information in the wiki platform.
But the interesting philosophical questions comes when what is really worth automating and what is not that good when we automate. So what is really going in the benefit of autonomy and in the benefit of freedom, and what is in the other direction. And I think this is something worth considering. So, for example, in this case of glossaLAB, so I think that the kind of work that we are automating is not something that is really worth. So is, you know, from our perspective, it's much better to invest it into more the creative work of just putting the form in clarifying the context that just in this thing, which is very tedious, that the word that Antonio was using. So taking away the tedious work and letting so the more creative one. So I don't know, what is your point of view with respect to automation? Yes, Rafael.
Yeah, very interesting. Yes, this is what we are doing all the time. I am not very young anymore. In the 70s, when we started creating the INIS database, International Nuclear Information System in Vienna, and it was the issue how to bring all this huge information, articles and books and so on nuclear energy from all over the world, particularly from the Eastern world, from Russia and so on, into one system, which was the INIS system. And so the issue was, of course, an issue of automating and matching, as you described this, and to create a kind of format in order to analyze and to make searches possible. So, but it was in the 70s. It was about creating a database for scientific purposes, well, scientific, technical, and political purposes, of course, lastly. And the difference I see from the 70s to now, so 50 years later, is as the context is not anymore this system, the context of INI system, International Atomic Energy Agency, and Vienna, and the fight between the East and the West, and so on. But it is a global system under the premises of the internet, and everybody is trying to do matches and so on. And this is not working very well, to put it very simply, because at the moment, and you go into the internet and you put some prints of yourself, and any search is let prints of yourself, any search, and this can be used and is being used by many players of the whole system worldwide, for good purposes and for bad purposes. And this is extremely complex. I cannot see any solution from outside of the system, and so we have to muddle through this issue in some way to get some rules of good functioning and so on. But it is extremely difficult when you give up your autonomy, and you do it every time you go into the internet. Just now, exactly just now, you interlace some footprints, and you never know who for what is going to use these footprints in the internet. And this is for me the most basic issue between what you said, José María, between autonomy and automation. I think it is a basic issue of our time. We thought we were more autonomous with automation, but in fact we are becoming less autonomous with automation at this the big picture of the internet. In a small system, it's I agree with you, Antonio. Of course, it is you cannot do it by hand and so on, an encyclopedia, and we are happy to have to do this. But in the context of the internet, of the whole cybernetic system we are now part of, it becomes more and more complex, and I have no solution for that.
Yeah, I completely agree. Yeah. So this morning we were talking about that.
Sorry, I was not part of the system this morning.
No, not only you. Yeah, but this what I presented before about the cybersubsidiarity, in a sense, this is what is trying to state as a kind of solution for the fact that we are setting the information for different purposes that are alien to the purposes of what we are doing. So the idea of the cyber subsidiarity model is that information should actually circulate at the level of where the problems are at stake, and the information should serve to that purpose, not when it goes to something else, like what happens. So when we use Google and when we use Facebook and so on, that's taken for different purposes. So all those information exchanges is not for the purpose of the communication. So all that exists because other issues or other problems, other interests, other objectives are being pursued. And of course the situation is dramatic. So I put an example to both, compare interestingly. So one of the industries that was most automated in the 90s, that was the automobile industry. See, compare what happened with the digital giants today, and the relation between the economic value, so the market value, with respect to the working force that it represents. So it has decreased. So for the workers, 100 times. So that means before we were complaining and saying the automation is dangerous because people are losing their jobs, and this was actually put forward by Norbert Wiener in very early, so in the 60s, and they called to the unions and said you should be worried about that. And then in the 80s, it was people were thinking, how can we use automation for other purposes? And in the 90s, we were criticizing. So this is a big issue. We should do something. And now it's actually 100 times worse. So a huge company like Alphabet, it has practically no worker. So it's lesser than 100,000. So that's practically no working force. So the automation at that level is incredible. So of course I completely agree with the problem in the internet. So what I don't know is, so how can we do that we could organize the information system as we could? So I don't know whether we can do it at our level. We can try to do it at our level and see that it works. But of course, the driving forces is not at our reach. The driving forces of how the internet is working. So, but at least we have to try to propose.
There's maybe another point worth mentioning. That is, the machines don't work exactly the same way people do. They don't have the meaning, the context. And sometimes the results are confusing for people. And the more we rely on them, sometimes the more confused we are, because we don't understand how they came to the results. And maybe the results are different than people would achieve. And that also makes out of the world something not so inhabitable for people, which is dangerous, maybe confusing, puzzling. That's another consequence of this automation which is being introduced. It's not only, it can be used for different purposes. That's one problem. Another one is that we are producing a world which can miss the sense, the meaning, the understanding for people. That's another problem.
Yeah, so the important part of that automation is that it touches what we are thinking, what we are believing, what we are communicating with each other. Is different to something that, so we are kind of automated in the sense that our cells work automatically. So we don't need to think in how the cells work, how the cells communicate with each other. They just work and they do the job, so to say. Yeah. So we don't even need to think in when we walk. So our body knows how to walk, and we can concentrate. For example, if we are going besides our girlfriend or boyfriend, we can concentrate in them, or in the sunset, but it is automated. The rest is automated. So I mean, automation is not necessarily bad, but it is touching our attention. So where we put our focus, and it's trying to detract the attention, which is the most important part of us. You know what I mean? So what our objectives, our beliefs, our so relations with the others, and it's driving that, which is maybe the most substantial part that we should be in the capacity of having a control of it.
Yeah. Okay.
Yes, please, Rafael.
Yeah, just let me a small remark on Aristotle, book 2 of his Physics, where he discusses the famous 4 causes, causality, Aristotelian causality. But in the book 2, the second book of the Physics, he says there are 2 more causalities, forms of causality, which he calls katatouche, which means by chance, and katautomatos, which means also by chance, but in nature. So there are things in human action, with the praxis in Aristotelian terms, which happens by chance, katatouche, which is good chance and bad chance, of course. And you cannot avoid these. That is part of the causality of human action, specifically human action. And then he says, in nature, there's also things that happen by chance, and he called this katautomatos. So it belongs to physis in the Aristotelian sense, in the Greek sense, that many things are caused by different basic causes Aristotle explains, but many things are caused by chance, katautomatos. And I think it belongs to the things itself. What is for us, for me at least, interesting is that in systems that we're supposed to exclude chance or exclude other causes than necessary ones we want to, they play an important role now in complex technical systems, not just in human action, in praxis, and not just in nature and physics, but also in technical systems. And this is very, very interesting, because we cannot apply these two Aristotelian concepts of katatouche and katautomatos. This is a kind of both, because it is a human product, which means it includes always some kind of chance in any human action, including the technical action, things you cannot foresee, everything. And it is also part of nature, because all technical systems are, of course, with matter and so on, and they include also a kind of katautomatos, of changes in the nature of the matter of the technical systems. But in the modern view, technical systems were supposed to exclude chance and to work according to the necessity of the human intention. And what is happening now in these complex cyber systems, which were supposed to be dominated by us, is exactly the contrary. And this makes me hopeful that maybe we can try to understand better what we are doing, and not to dominate it, just to understand better. And this would be a further step into dealing with technology in another way we have to do it until now. I don't know if it was complex. Excuse me for going back to the old Greeks, but sometimes it helps. Yeah.
You are mute again. No.
Yeah. No, thank you. It was not complex. It was very nice to hear and to recall Aristotle.
Yeah, these unwished consequences or unintended consequences are very interesting. Yeah, I agree.
Yeah, of course, some of the most important things that happen in our life, like for example, love, chance always played a very important role. Without the chance, of course, that's important. When I said before that there are things that we need to have more control of, it is that we are giving the control to some alien purposes, because this is being taken into the benefit of of the profit of Google and Facebook and so on. That this is increasing the worth value of them instead of enabling. So what we really need to do. So we want to have relations. We need to know, and instead of doing that, then people Google. You know, I say this because I always when I came to Berlin, I asked it to a driver because I was sure that the driver would know very well so how to arrive to one specific point, and he answered me automatically, Google it. So I was expecting a more expertise answer. Okay, so thank you very much. Any other comment? No. Teresa told me that she couldn't participate and answer was sick. Isaac. So then we can finish for today. Okay, so if you want, do you want asking something about the arrangements? So what is expected to have? So by the way, I can say for tomorrow, we are not going to start at 10 in the morning, but we are going to start at 11 in the morning because we have an appointment at 10. Okay. Besides that, the rest of the program, it doesn't contain much change. I will announce when it comes.
Okay.
So thank you very much for your participation, and so we will deliver so also the contents later. So when we have the time to put it together. And see you then tomorrow or when you can, in the next occasion. Thank you very much.
Okay. Thank you. See you.
See you.